In this problem, we're given the spring constant and mass for a simple harmonic oscillator, and we're looking at this initial state where the mass is passing through the equilibrium position with a known speed of 4.5 meters per second. And we're asked two questions about this thing. First, we want to find the amplitude of the oscillations, and then second, we want to compute the maximum acceleration of this mass. So finding the amplitude is an energy conservation problem. What's happening there is in our initial state, while the mass passes through the equilibrium position, all the energy is kinetic energy. The spring is at its relaxed length at that one special point, so there's no spring potential energy. And then when we reach the maximum extension of the spring as the object is turning around, well, it's going to be stationary at that location. In other words, V is 0 and there's no kinetic energy. And the value of x there is the amplitude of oscillations. So we'll start by saying E initial equals E final. And again, in the initial state, it's all kinetic energy. So we have 1/2 mv squared. And then in the final state, it's all spring potential energy. So we have a 1/2 kx squared. But there's a special name for the maximum x there. That is the amplitude. So I'm going to say 1/2 ka squared. And our 1/2s will cancel out. And we can go ahead and solve symbolically for a here. We just divide both sides by k and then square root the result. So the amplitude is going to be mv squared divided by k, where the v is the velocity as the mass was passing through the equilibrium position. And then we take the square root. So now we just have to plug in all the given quantities. We were told the mass of this oscillator is 250 grams. Make sure you change that to kilograms. So I have to write it as 0.250 kilograms. The speed as it passed through equilibrium was 4.5 meters per second, and we need to square that. And the spring constant was 28 newtons per meter. And when we run the numbers on this to 3 significant digits, we find an amplitude of 0.425 meters. Now in part B, we're asked to find the maximum acceleration of the mass. And this is going to occur when the mass is feeling the maximum force. And the maximum force exerted by that spring is going to happen at that point of maximum extension, or on the other side of the equilibrium position, it'll happen at the maximum compression point of the spring. And that's why part A came first. We already have the amplitude telling us the maximum extension or compression of the spring. So now we can use Hooke's law to find the size of the force at that point. So just writing down Hooke's law in terms of magnitudes here. I'm not concerned with using a minus sign for direction. I just want to know how big the force is. That's F equals kx. And what we're trying to find is the maximum force that corresponds to the maximum value of x, which is actually A, the amplitude of the oscillator. So we can find a number on the maximum force here. We just sub in our spring constant of 28 newtons per meter, sub in our amplitude of 0.425 meters, and we find a maximum force of 11.9 newtons. Now we can get the acceleration of the mass by using Newton's second law. So A is equal to F over m, and I'll go ahead and indicate here. I'm talking about A max corresponding to F max. So my max acceleration is going to be 11.9 newtons divided by the mass of this oscillator, which again, in SI base units is 0.250 kilograms. And we arrive at a maximum acceleration of 47.6 meters per second squared. So at the location I showed in the second picture here, that acceleration is going to point to the left. The spring is pulling to the left with 11.9 newtons there, and the mass accelerates to the left at 47.6 meters per second squared. But remember, on the other side of the equilibrium position, we're going to end up with a maximum distance from equilibrium of, again, 0.425 meters, but this time to the left of the equilibrium position. And the spring is going to exert the same magnitude of force to the right. And we'll see that maximum acceleration again of 47.6 meters per second squared, this time pointing to the right. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left. Or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.